Hello folks, today we're going to talk about the mole family, which is the 40s. We're going to go through the top. Feel free to pause the video at any point in time that you need to do so. The first question, H2O is a molecule. Pause the video, see if you can figure out these next two, then I'll go over them. H2O is made up of two atoms of hydrogen and one atom of oxygen. Again, pause the video and see if you can do this next one on your own. In 1 mole of H2O molecules, water molecules, there would be 2 moles of hydrogen and 1 mole of oxygen atoms. Subscripts can be read as mole ratios. Mole ratios have infinite number of sig figs. Pause the video, see if you can go through number 4 on your own before watching me go over it. This whole problem is kind of relating moles as being a name for a number, as is dozen is a name for a number. So in 1 dozen molecules of silver sulfide, how many dozen silver atoms are there? Well, this 2 says that there's 2 silvers in every silver sulfide. So if I have a dozen molecules of silver sulfide, I must have 2 dozen silver atoms. Pause the video, contemplate that, think about that, see if that makes sense. In 1 million silver sulfide molecules, there are how many silver atoms? Well, if I have 1 million of that molecule right there, and there's 2 silvers in every one of those molecules, I would have 2 million silver atoms. Again, contemplate that, think about that before you go any further. In 1 mole of silver sulfide molecules, there's how many silver atoms? Well, in 1 of these molecules, I always have twice as many silvers, so this would be 2 moles of silver atoms. Again, subscripts can be read as mole ratios, and mole ratios have an infinite number of sig figs. So now we're going to start doing some mathematical problems. We are going to be going from Mole Island to Mole Island today, and this bridge right here is called Subscript Bridge. Those are those little numbers like in H2O. That is a subscript, and these have infinite number of sig figs. That might be something you want to pause the video right now and go to the cover of your unit pack and make sure you have that information. So let's start this problem. Like all of our chemical problems, we want to start with the number and the label that they give us. So we're going to start with 5.29 moles of silver sulfide. As in all the problems that we do, whatever label is right there goes on the bottom of the next step. So we put moles of Ag2S right there. So we're at Mole Island right here. This is Ag2S. That's what we have for our substance 1. And in this problem, we're going to be going to atoms of silver. Silver and silver sulfide are not the same thing, so we're going to go to a second substance. And this substance down here is going to be what they want us to go to, which is going to be Ag, or silver. So we are going to go to moles of silver, and we are going to go across this bridge. So we go from moles to moles. We have moles right there, we have moles right there. We're going from one substance to the next. But this problem wants atoms of silver. So we have to go one step further. Whatever I have for a label right there, I put for a label down here. So moles of silver. And at moles of silver, I can go over to atoms. So I can go right over here to atoms. And I got to go across this bridge. So I can type or write atoms of silver right here. So again, our pathway went like this and like this. Each bridge is a multiplication sign, so I have two multiplication signs because I went across two bridges. Let's pop in some numbers. So right here we have moles over moles. How many moles of silver do I have in a mole of silver sulfide? Well, that was that problem that we just did above. In here, we can see there's a 2 for a subscript, and this bridge right here is called subscript bridge. So there are 2 moles of silver in every 1 mole of Ag2S. Again, that 2 came from that subscript right there. When we go over to atoms and moles, this next step, we are going across this bridge right here, and that's 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd is a huge number. We call that the mole number, and that number won't go with the mole label, because then we would have a mole of moles. So 6.02 times 10 to the 23rd atoms are in 1 mole of silver. You crunch all those numbers, and you should get, for an answer, 6.37 times 10 to the 24th atoms of silver. Make sure you try that on your calculator to see if you get the correct answer. If you're getting a slightly different answer, you're pushing it into your calculator wrong, and we need to assist you with that. Number 6 is a similar problem. We're going to be going from mole island to mole island again. In this problem, it starts us off with 2 moles of nitrogen gas. First of all, we need to realize that nitrogen gas is N2. I would encourage you to try this problem first, then watch me go through it after that. So we're going to start this problem, 2.0 moles of N2, multiplication sign, division bar. Whatever we have for a label here goes on the bottom of the next step. Moles of N2. So right now we're on mole island. This is N2. In this problem, it wants us to go to atoms of N. Well, N and N2 are different, so this would be mole island for N. So it looks like this problem is going to be very similar to the last problem. We can go from mole island. We can go from this mole island right here to this mole island right here by going across this bridge called subscript bridge. So we can go to moles of N. So right now we are down here. We don't want our answer in moles of N. We want it in atoms of N. So moles of N go down here. And we are going to go over here. And we have to go across that bridge. So we again can go from moles to atoms. So atoms of N go on top. Try to pop in the numbers, pause the video, pop in the numbers, see how you do, crunch the numbers, see how you do, and then turn it back on and I'll go through it. So right here, we have moles to moles, mole island to mole island. The name of that bridge is subscript bridge. We only have 1 subscript there. So in every mole, 1 mole of N2, there are 2 moles of N. This 2 comes from right there. When we go from mole island to atom island, 6.02 times 10 to the 23rd comes into play. So that's that bridge right there, 6.02 times 10 to the 23rd. So that's 6.02 times 10 to the 23rd atoms in 1 mole of nitrogen. You crunch that number, and with correct sig figs, the answer is 2.4 times 10 to the 24th atoms of N. Again, if you're not getting that as your answer, you should come in for some help because you are putting things into your calculator wrong. The rest of it is homework for you.